Okay, growing annuities. Just like perpetuity, growing perpetuities, this is an annuity where the payments grow each period at a constant rate. So let's write down the terms, growth rate, discount rate, the first payment, and length of the annuity. Growth rate is G is growth rate of payments. R is discount rate. $C1 is the first period payment. And T is length of annuity. So in general, if I wanted to know the payment for time t plus 1, little t, that's equal to the payment for time t times 1 plus g. And if you kind of iterate this, you will find that that is equal to first payment times 1 plus g raised to the power t plus 1. So if you wanted to know payment for time period 10, then t is 9. That would be 1 plus g to the power 10 times the first period payment. To calculate the value of this, we're going to use a similar approach. We're going to divide the timeline into two parts. We're going to call this first part, let's use our eraser. Come on, eraser. All right. I'm going to call this part the growing annuity. I'm going to call this part GB. It's like a delayed growing perpetuity. And this part, a growing perpetuity. Now, we know how to calculate present value of a growing perpetuity. You already watched that video. So present value of a growing perpetuity is first period payment divided by R minus G. That's good. So if you can come up with a formula for GB, present value of GB, we're home. Then present value of GA, or the growing annuity, is the difference between the two. Notice that GB is also a growing perpetuity that starts first payment at time t plus 1. And if you look at the formula for growing perpetuity's present value, you notice that the numerator is the first payment. So what is the first payment for GB? Well, that's going to be $C t plus 1, because the first payment of GB is going to be on period t plus 1. Well, we have the formula upstairs, C1 times 1 plus G to the power T. So if we transport ourselves to the beginning end of time period T, cap T, from that point on, GB is a growing perpetuity. So at that point, we would value GB as of time period T as the ratio of the first payment they're going to get divided by R minus G. And we also already know what that is. Done. But this is the value as of time period T. We need to discount that to today. Present value of GB as of now, or present value of GB, is present value in the future divided by 1 plus r raised to the power t. That means 1 plus g over 1 plus r raised to the power t. Now our job is easy. Present value of a growing annuity is present value of growing perpetuity minus that animal PVGB. That's $C1 R minus G minus $C1 R minus G multiplied by 1 plus G over 1 plus R raised to the power T. Collecting terms, we come up with one ugly formula. I'm going to kind of do a shorthand. Let's call R star R minus G divided by 1 plus G. It's easy to show that 1 plus R star is equal to R minus G, 1 plus G plus 1, or R minus G plus 1 plus G over 1 plus G. G's cancel out, 1 plus over 1 plus G. That means 1 plus G over 1 plus R is the same thing as 1 over 1 plus R star. This is going to make our job easy when we're making calculations in Excel. So in terms of R star, also note that R star is R minus G divided by, this is R, not A, 1 plus G. That means R minus G is equal to R star times 1 plus G. So let's write down our formula again. Present value of a growing annuity is $C1 R minus G times 1 minus 1 plus G over 1 plus R raised to the power T. Well, 1 plus G over 1 plus R is equal to 1 over 1 plus R star. R minus G is equal to R star times 1 plus G. Plugging those in, we get $C1 R minus G, not R minus G this time, R star. Come on, eraser. Times 1 plus G times 1 minus 1 over 1 plus R star raised to the power T. This looks awfully like the formula for present value for regular annuity. In fact, if we wrote this as 1 over 1 plus G times C1 over R star times 1 minus 1 over 1 plus R star raised to the power T. This is a regular annuity where the payments are C1 for each period, but discount rate is R star. So if I do the following, PVA R star G, PVA R star, this is present value of a regular annuity where payments are $C1 every period, but those payments are discounted at a rate of R star. Then present value of a growing annuity where you have R as discount rate, first payment is C1, and the growth rate is C, is simply equal to present value of a regular annuity. Payments are C1, discount rate is R star, and divide the whole thing by 1 plus G. This is going to help us a lot when we make these calculations in Excel. And I'll basically talk about how to do it in Excel. I don't want to spend time here and confuse you. The purpose of this little video was to kind of create a basis for that Excel application. In the next video, I'm going to talk about how to calculate forward value or future value of a regular annuity and growing annuity. For now, we'll stop here, and next video we'll do future values. Then we'll make implementations in Excel.